Hello everyone. We're going to do the linear analysis of 2D frame. This is just beginning how to do analysis. I'm going to show you, and in this video I'm going to show you the deformed shape and the axial force diagram stress in the member. Okay, I'm just showing this an example. We are going to use the civil and structure plus. Yeah, we'll create a new model, a linear analysis of 2D frame. Analysis start with the structure and analysis category is 2D in frame. And this is the model unit we are using Newton, meter, kg, second. And start of template we are using 2D frame. We can define the title by yourself, job number by yourself. Okay. Okay, I'll write it. I have already done this one previously. So first, to do the analysis, we are going to define a frame. For the frame, we are going to define the point coordinates. We are going to define the coordinates by coordinates which we are using. If we draw once the left side of the truss, then right side we can replicate it. First, now I'm going to show how to write the points. This strings F. Next point I have got I got 0, 3, 0. X is 4, 3, 0, 4, 4. Height is also 4. X, Z, X, that is that's these are points. Now we are going to draw the lines. We select the two points and we go to attribute geometry line by points and straight line, and we can select we can select these two lines and draw by here. Is also we have lines for here. There is we have got 2 points selected lines, and we're going to select this one, shift another point and lines, and we're going to divide this. We have two middle point of these two lines. We're going to divide this point line geometry line splitting two, and we're going to join these two lines. Okay. Now we're going to we are going to meshing of the line. We're going to divide the line into number of lines. For that, we're going to mesh it. We're going to geometry. We're going to attribute mesh line. Mesh line is we have thick beam, linear, a number of division 4. We can write it. We can write it thick beam linear. Okay, and we're selecting all, and we're assigning the thick beam. Yeah, we can see this after we assign the colors in here. Now we're going to define the materials. We're going to define the geometry. When we're going to define the material, we're going to steel, UK, spinels is fine, grade on grade. We can write it mild steel. This is the geometric properties. Yeah, we got it understood, and we're going to assign it mild steel. Okay, assign to line. Now we're going to define the we're going to have the define section where we need the section, which section we are going to use. Then we need to define the section. Oh, sorry. We define the materials and define the section, geometry section. For that, which beams we are using. For the UK, we are going to use the UK beam, units of beam, and we are going to use 127 30 keys. This is for only for practice. We can get it like the beam. We can name it 127 76. I would write place 13. Okay. 30. Okay. And for the roof, we are going to I section. So at any section, the section, we are going to European Unions angles, unequal angles. And I am going to use for this. Yeah, I'm going to use 70, 76. I'm going to use 70, 70, 70. I'm sure. Sorry. I'm going to equal angle. Sorry, equal angle 70, 76, 70, 76. And we say equal angle. Yeah. For the for the roof, we are using the equal angle. So select this one and assign it to the equal angle. Assign to line here. And for this one is our beam. Assign the value to beam. We have assigned the material meshing. We have defined the geometric properties. We have defined the material properties. Now we are going to define the support. Support we are going to use fully fixed. Yeah, fully fixed support we are using. If we click pressing OK, we are going to replicate this one. Yeah, we are going to replicate it. For this, we are going to we're, um, sorry. Mm, We're going to replicate it. For this, we're going to do geometry line. Geometry line. No, I'm going to, sorry, so I have not selected geometry line, copy, when to make mirror, when to is parallel to y-axis, because we are going to x direction. This is y-axis, parallel to y-axis, and for general x direction should be, position should be, it should start after the 4 meter, and z should be 0 from this point, 0, and next point we will go to 4 meter, and the height of that will be the 3 meter. That's the group of this two, this three. So we're going to replicate it. Let's replicate this one, and we're going to see the geometry properties. Let's see line direction. We can see that line direction is this is going this one, but we need to reverse it. So we're um, going to going to reverse the line. So we're going to geometry line, and we're going to reverse the direction. Now it's fine. After that, we have defined our model with everything. Now we're going to define the load case. For that, we are defining the self weight. For loading, we are defining self weight. We're using the self weight. So we are using the body force index, and it is going downward, means minus 9.81. Between that is self weight. Yeah. And we are going to define another one, sway load. So we are going to attributes loading. That is the sway load really concentrated. We are going to apply at the points. So next, and it will apply to 500 kilonewton, and it is this sway load. Yeah. Now we are going to assign the load. First, we will assign the self load. Self load case 1, assign to line load case 1, and after that we are going to assign the load case 2, and we'll define it load case 2 locus 2. Okay. Okay. So we have defined out loud everything. Now we're going to analyze. Now we're going to analyze the load. We're going to run the analysis. Let's analysis 1. We can see our deform mm, load case. Now if we define the loads active, you can see this one. Now for showing the both effect, we're going to define a combination. Basic combination. We'll define our basic combination. So it will be SI analysis basic combination and select this two, this one combination one that make communication one active. We can see our deformed shape by both combination. Uh, yeah. If we want to set the value, we give value displacement. We can see the displacement value range. We can add significant flow. Second flow magnification. We can change it from 100. Okay, we can see the value, but it's showing so much massive, so we can save so value on selection. We can see if we select here, so if we select here, we can see the value. Now we're going to we can show the displacement value. Now I'm going to show you the we'll make it off. I'm going to show you the trigrams for fx axial force trigrams. Axial force trigrams. I'm going to show you 100 level only unselected. Okay. We select look axial force trigram. See this one, yeah. Then to see the mm, shear force diagrams, can go to y directions and see the shear force diagrams. And for the movement diagrams, yeah, movement we can see like this. You can see all the diagrams we can see from here. And can do like this. Everything can shown. We can view isometric view from here like this. Isometric view. Okay. For the easy, I'm doing this one only. Yeah. After that, I'll turn it off, and I will show you the shear diagrams. Contour displacement. I can show you force. I will show force and movement diagram effects. Okay. Yeah. We can see the maximum value. I can show you the stress also. Stress diagrams here. Stress diagram. We can see it more stress. And from here we can see everything. From contour diagrams, we can see displacement also, force and movement fy direction. Can apply it, and you see the value. Maximum value is 163. The 163. This one is maximum value. You're getting. By this way, we can see all the value. We stress diagrams, everything we can see it. Now I'm going to show you how to create the model. So for that, we'll go to utility, reporting, new model. We can use report dot I report. You can write report. Okay, and each report. We can add the chapter. I will add all the chapters. We can see the result also. Here we can go result displacement. You can add all the displacement. You can add response unit. Add displacement. You can write displacement. Displacement. You want to add another one? Stress, force and dragons. You can add force and dragons, and okay. And after that, you can withdraw it. You can export it, and you can save it. Anywhere you can save it. By this way, we can show your stress, axial force, shear force, and bending dragons, and we can see your report also. Thank you for watching. Yes, yeah, we can see here. We'll get the all value. This is the table, loading combination, everything we can extract it, we get it. Yeah, thank you for watching.